If you're building AI for the enterprise, you already know the struggle, right? You need all that power, but you also need privacy, you need control. So in this explainer, we're going to break down a whole new way of thinking that lets you have both by building these really sophisticated AI agents right on your own machine. Okay, so let's just dive right into the heart of the problem. This is the dilemma every single AI developer is facing today. Over on one side, you've got these incredible cloud models, but they come with huge strings attached, data privacy risks, network latency that kills real-time apps, and costs that can spiral out of control. And then on the other side, you have local models. They're secure, they're fast, but let's be honest, you often hit a wall with the limited models and the lack of really solid frameworks to build on. It feels like you're forced into an impossible choice. But what if that whole dilemma is just a false choice? What if there's a way to get the best of both worlds? I'm talking about the power of a really sophisticated AI ecosystem, but with all the security and the speed you get from local development. So let's look at the first piece of this puzzle, Foundry Local. The easiest way to think about this is like your own private high-performance AI engine. It's a local runtime that literally brings Microsoft's whole AI ecosystem down to your machine. And that means all your data, all the model's thinking, it all happens right there with you. Okay, so if Foundry Local is the engine, what's telling it what to do? Well, that's where the Microsoft Agent Framework, or MAF, comes in. Think of it as the conductor of your orchestra. It's the framework that lets you build and test and manage those really complex multi-step AI agents. It's the intelligence that's directing all that engine power. So when you put these two things together, the benefits are immediate and they are huge. First off, your data stays private. Period. You completely eliminate network latency, which is a game changer for real-time apps. You get control over your costs because you're not paying for every single API call. And maybe the most important thing for developers, you can iterate and debug at lightning speed. All right, theory is great, but let's get practical. We're actually going to walk through the entire journey of building a pretty sophisticated deep research agent using this exact local-first approach. And this whole journey, it really breaks down into 4 clear logical stages. We're going to start with security, got to make it safe. Then we'll move into designing the core logic, then debugging it, and finally optimizing it to make it ready for production. First things first, before we write a single line of the agent's real logic, we have to make sure the foundation is rock solid and, most importantly, safe. And that means we have to stress test our model to really understand its boundaries. We do this using the technique called red teaming. This is so important. We're not just crossing our fingers and hoping the agent is safe. We are actively and systematically trying to break it. We're throwing adversarial prompts at it to find and fix those vulnerabilities before they ever become a real problem. And what's really cool here is that this isn't just guesswork. We're using really specific attack strategies, like prompt injection or using lead speak to swap out characters to test the model against very defined risk categories. It's a methodical, almost scientific process to build a truly robust safety baseline. Okay, with that secure baseline in place, now we can have some fun and design the agent's core intelligence. For a research agent, that's this really cool iterative loop. It goes out and researches a topic, it judges how complete the information is, and then it decides if it needs to go back and dig even deeper. The real beauty of this whole workflow is how modular it is. You have these distinct, separate components, a research agent that just gathers info, an iteration controller that's the decision maker, and a final reporter that pulls it all together. Each part has one job, and that makes the whole system so much easier to understand, to test, and to build on later. All right, next up, we're going to tackle one of the biggest headaches in all of AI development, debugging. You know that feeling, right? Agents can feel like a total black box. You send a prompt in, something comes out, but you have no clue what just happened in between. We need to turn that black box into a glass box. And this is exactly where the Agent Framework's Dev UI comes in. It's like having X-ray vision for your agent. You can see the entire workflow laid out visually, watch it execute step by step, and you can even inject new parameters while it's running to test different scenarios. It completely transforms debugging from this frustrating chore into a fast, interactive process. So at this point, our agent is secure, it's smart, and we can actually see what it's doing. The final step is to get it ready for the real world, make it production ready. And that means we have to focus squarely on performance, efficiency, and of course, reliability. To do this right, you need data, not guesswork. By hooking into observability tools, something like .NET Aspire, for example, you can track all these key metrics like end-to-end latency, how long the model takes to think, or the overhead from calling a tool. This lets you pinpoint the exact bottlenecks and make smart, informed decisions to optimize your agent. So let's just zoom out for a second. What we've just walked through isn't just a collection of tools. It's actually a new architecture, a new way of thinking about building AI applications that's structured in 3 distinct layers. At the very bottom, you have the foundation. This is the model itself, running locally thanks to Foundry Local. It's the raw intelligence, the engine providing that reliable inference. Layered right on top of that is the logic layer. This is the agent. This is where you put your specific business logic, where you give the model a purpose and connect it to tools, like a web search. And then, at the very highest level, you have the process. This is the orchestration that's managed by the agent framework. This is the layer that handles those complex, multi-step workflows, just like our research judge, research again loop. So what this all really means is that you're making a fundamental shift. You're moving away from just making simple API calls to a model, and you're moving towards designing, managing, and observing an entire intelligent system. And this framework-first approach, this is the key that finally bridges that huge gap between a cool proof of concept and a truly robust, production-grade application. So let's bring it all home. What does this new superpower of local, controllable, and framework-driven AI really mean for you as a developer? What does it give you? Well, it gives you total control over the entire AI lifecycle. You get security that you can actually verify. You get orchestration that makes really complex logic feel simple and maintainable. You get development cycles that are radically shorter because of that instant feedback. And you get performance that you can measure and optimize with real data. You're no longer just a consumer of a black box model. You are the architect of an intelligent system. Ultimately, this combination of Foundry Local and the agent framework puts powerful, private, and truly production-ready AI directly into your hands. It's your data, your rules, and your AI. So the only question left is, what are you going to build first?